Hello, we are discussing the 2022 Digital Electronics paper that appeared in Rajasthan Technical University exam, and we have reached solving the questions from part A and B to question in part C. Part C is of 10 marks and we have to attempt only 3 out of these 5 questions. So this one is quite easy to answer. Question number 1, we will start solving from 1. Realize all gates by using NAND and NOR gate. So this part I will take in this video. So I have searched online and have got good resources. First is realizing NAND and NOR gates. There is a document in which NAND and NOR gates are explained. What is a NAND gate? Symbol, truth table, Boolean function. It is not of AND. And then what is a NOR gate? And they both are universal gates because they can implement any other gate without needing anything else. Only these gates themselves repeatedly used can produce any other logic. Advantage is that they are economical to use and easier to fabricate, to construct, to make, develop, and these are the basic gates that are used in the IC digital logic families, that is related to manufacturing. So we use these rather than we use simple AND or NAND gates. We use these to make. Actually, AND gate is typically implemented with NAND gate, and it is not the other way around. So basically, NAND gates and NOR gates are used to design chips, digital circuits, and everything. So AND or NOR function is actually available using the universal gates. So we will begin with NAND gate. Let us again revise the question. What was the question? Question is realize all gates using NAND gates. So we will begin answering that. First, we know these 3 gates are basic gates and we have to implement this using NAND gates. How will we go about it? The answer starts like this. We implement the first inverter gate by just connecting the input of the 2-input NAND gate, and then when input is fed, this complementation will complement the output and an inverter will be realized. So this is first implementation. Then the second implementation will be you got an NAND gate, then apply 2 inputs, you will get an output complemented, then use the previous inverter in cascade, and that will give you an AND operation. So this is the answer that you have to write. An OR gate is implemented by 3 NAND gates. Similarly, NOR gate will also be used to implement NOT gate, OR gate. This time cascading will give you the same OR function that is there, and then 3 gates will produce AND gate. So these are the ways in which you do that. And then there is this inverted input also. You call equivalence. You can read through it, but this need not be written. But still, if you write this, you will get 100% marks, because this is you are giving and AND gate which is equivalent to inverted input NOR gate. So this is another gate that can be shown, but not necessary in this answer. And this is 2-level implementations, product of sum of products. Again, this is not required in your answer, only the thing that was required I discussed. Then there is this lab manual also. I'll put the link in description section, in which it asks the same question and it gives you the IC number also. So you have the IC with you, you have the gate with you, you can implement the NOT gate, AND gate, OR gate, write the truth tables, and then this is how you can answer again in a different way, in a more it is clearer. Then we have some questions in GATE exam also, which are exactly same like this, but they have asked holistically minimum number of NAND gates required to implement a XOR gate. So NAND gates will be 4 and NOR gates will be 5 if you want to implement XOR function. Similarly, other functions also. Having seen this, I want to quote that the universal set comprises of NAND gate and NOR gate, and one more, multiplexers. Multiplexers can also implement any logic function. So we'll maybe the question comes, we'll discuss it later. And this link I will also provide. It gives you good designs on implementing say XNOR gate using universal gate NOR gate, and this is the part of answer. This is the answer that you have to give in your this question, BTech RTU question. Another good web page resource is this one, in which they have asked 2 input NAND gates are given. You have to implement solver gate. Minimum how many? You need 4 NAND gates, and this is the circuit, and this is a very good summary table. So if you want to be good at it, you just take one question and then build this gate using NAND gate and NOR gate, try to minimize it using Boolean algebra and find the number of gates, minimum gates that are required. And this table is really very good summary to generate so many questions. Directly from this, hundreds of questions can be put up. So if you understand, if you have studied well, I have presented the sample answer to this question. Thank you. Next question will be this in next video.